Hey YouTube, welcome back. Ever felt like your database queries are taking forever? Like your application is such in slow motion? Well, there is a fundamental technique that can dramatically speed things up. It's called indexing. And it's like giving your database a super fast lane. Okay, let's try to understand the speed deal analogy. So imagine trying to find a specific word in a massive dictionary. Without index, you would have to painstakingly flip through every single page until you stumble upon it. That's essentially what your database has to do when it runs a query on a large table without an index. It has to scan every single row, but with an index, it's like having like a speed dial, or or the index at the back of the book. I don't know if you know it. I guess you of course you know it. Sorry. It's a separate data structure that contains a subset of the data, cleverly organized to allow for incredibly fast lookups, helping your database jump directly to the information it needs. Okay, we need to understand how it works. So there are three things that we need to put in mind: the database table, the index creation, and the B tree or hash index registration. What is the relationship? So again, how does this magic happen? When you create an index on a specific column, the database essentially creates a separate, smaller data structure. This structure contains a copy of the value from the column, organized in a way that's optimized for searching, often using structures like B tree or a hash index that you can see here. Crucially, this index also contains pointers that directly link each indexed value back to the physical location of the complete row in the main table. So when you run a query that filters on an indexed column, the database can quickly look up the relevant values in the index and then use the pointers to jump directly to the matching rows in the actual table without having to scan everything. Okay, so we need to think about how to implement indexing. So there is two ways to implement it. There is a single column text index. Sorry, a single column index or a compensate index. So let's start with the single, not a single and compensate. Okay, here. Just single, not single and compensate. This is single and this is the compensate. Sorry, guys. So let's start with a single column index. This is the simplest form. If you frequently searching for or filtering by a single column, like a user email address, for example, you can create an index specifically on that column. The SQL command might look like that you are seeing here. This tells the database to create an index on the email column of users table. Here we have a compensate index. What if your query is often filtered by multiple columns together? That's where compensate index come in handy. These are indexes on two or more columns. The order of the columns in a compensate index is important. For example, if you often query orders by specific customer ID and then further filter by order date, for example, you would create an index like this. You can see here one for customer ID and order date. This index will be most effective for queries that filter on customer ID alone or both customer ID and order date in that specific order. Okay, next, when to use index. So there is four. I would say more than that, but let's start with four reasons to start index. So first, if you have frequent filtering, like when you often use like things like order by, sorry, no, order by is in the sorting group. Sorry. First, we have frequent filtering. So if your application frequently uses where clauses to filter data based on specific columns. Number two, we have here a sorting and grouping. Like when you often use ordered by, group by clauses, indexes on those columns can significantly speed up the sorting and grouping operation. Next, you can use them for optimizing joins. Like indexing is absolutely essential for optimizing joins operations between large tables. Next, you can use the read-heavy applications. Like if your application performs many more and read operations than write operations, indexing is a go-to technique to ensure fast data retrieval and a smooth user experience. Okay, next we want to talk about the trade-offs. There are two main trade-offs. The first one is slower write operations. Like while indexes makes read faster, they can slightly slow down write operations, like basically insert, delete, update, things like that. Every time you modify data, the database has to update any associated indexes to keep them as consistent. This adds a bit of overhead to write operations. Also, we have some sort of increased storage usage. Indexes are separate data structures, which means they consume additional disk space. For very large tables with many indexes, this storage overhead can become significant, sometimes even exceeding the size of the original table itself. Next, we want to talk about the balancing act. So it's crucial to remember that not every query benefits from an index. If a query needs to retrieve large portion of the table, the database might actually find it faster to just scan the entire table rather than using an index and then fetching the corresponding rows. Finally, over-indexing, having too many indexes on a table can actually degrade overall performance. The overhead of maintaining all those extra indexes during write operations can outweigh the benefits for read queries. Therefore, choosing the right indexes for your most frequent and performance critical queries is a critical balancing act that requires a careful consideration and analysis of your application's workloads. Okay, I guess we go to our conclusion. So indexing is a fundamental and incredibly powerful technique to significantly speed up your database queries and improve the responsive of your applications. By understanding how it works and its associated trade-offs, you can strategically use indexes to create much faster and more efficient database. It's truly your database speed dial. So yeah, that's it for this video. And if you like you like this video, give it a subscribe and hit the notification button, and give me like if you want to say anything about the if you have like any more thoughts, or you found this explanation of indexing is not that good, just feel free to put a comment in the comment section below. So until then, see you quite soon.